Welcome to today's mathematics class. The last lesson we were handling solving equations using the inspection method. Now we want to look at the equivalent equations and what we mean by an equivalent equation. When you're looking at equivalent equation, this is what we mean. An equation is termed equivalent when it satisfies the following 5 conditions. This is what is happening so that the equation qualifies to be called an equivalent equation. An equivalent equation is obtained we will say that an equation is equivalent if it is possible to add a number on both sides. So if a number can be added on both sides of the equation, that is the right-hand side and the left-hand side of an equation, then this equation will be called an equivalent equation. So we are saying this: if I'm having an equation like x minus 5 is equal to 9, then I add a number on both sides. If I'm going to add a number on the two sides that will make the equation to be equal, then this equation will be equivalent. For instance, I can decide to add 5, so that I'm adding 5 on this side, then I have plus 5 on the right-hand side. So if I'm adding a digit on both sides of a given equation, then the equation will be an equivalent equation, in that if I'm adding 5, I have negative 5 plus 5, I'll get 0, so that I'll have my value for x will be equal to 14. So this is an equivalent equation because I can add a digit on both sides and get whatever I need. I get a solution at the end of it all. So we can say that an equation is equivalent if it is possible for us to add a digit or a number on both sides, be it the left-hand side and at the right-hand side of the given equation. So the same number being added on the left-hand side and the right-hand side will make an equation to be called an equivalent equation. An equivalent equation, we can say that an equation is also equivalent if it is possible to subtract a number on both sides. So if we subtract a number on both sides, subtracting a number on both sides will make an equation to be an equivalent equation. In that, for instance, I'm having such like a number. If I have such like an equation, then I decide to subtract a number on both sides. If I subtract a number on both sides, the left-hand side, the same number, I subtract it on the right-hand side. It makes my equation an equivalent. In that, if in this case I need to get the value of p, for instance, I will have to subtract 6 on both sides, so that I'm having p plus 6 minus 6 will be equal to 12 minus 6. So this means that the value of p will be 6. So I've subtracted a number on both sides. If an equation, it is possible for want to subtract a number on both sides, then whatever we are having is an equivalent equation, in that this side is equivalent to the right-hand side. Another condition that can make an equation to be an equivalent equation, an equation can be said to be equivalent if when multiplying a number on both sides and the number that we are multiplying with is not 0. So we are multiplying a number on both sides, but the condition is the number that we are multiplying with on both sides is not a 0. So when you're having an equation whereby it is possible to multiply a number on both sides, for instance, we could be having a question like if I have a question like y over 4 is equal to 2, then it means that if I need to get the value of y in this given situation, it is possible for me to multiply both sides by 4. I can multiply the left-hand side of the equation by 4, multiply the right-hand side of the equation by 4. So we are multiplying both sides by 4 so that our value for y is 8. So I have an equation. The number I'm multiplying with on both sides is not a 0. So it means that this will make my equation to be an equivalent equation. Equivalent equations can be obtained also by dividing both sides by a number. And still with the division, we are dividing by a number, and this number should not be a 0. So we are dividing both sides by a number, but the number that we are dividing both sides with should not be a 0. For instance, if I'm having such like an equation, I have 2x is equal to 10. In such like an equation, I can obtain the value of x by simply dividing both sides by 2. We are dividing by a number that is not a 0, and 2 in this case is not a 0. So if I decide to divide here by 2, divide by 2, so that my value for x will be obtained by 10 over 2, which is 5. So this means that I've divided both sides by a digit. There is a number that I can divide with on both sides so that I get the respected value, the value of my unknown. So it means that the number that I've divided with is not a 0. And this repeated division of a number will bring about an equivalent equation, because it is possible for me to divide the left-hand side and also on the right-hand side by this number, which is not a 0. If we have an equation where it is possible for us to swap the left-hand side with the right-hand side, then we are saying that the equation is suitable to be called an equivalent equation. What do we mean? We are having such like an equation where it is possible for us to swap the left hand side and the right hand side. For instance, I'm having an equation. My left hand side has an expression of 5x plus 3. My right hand side has an expression of 2x plus 9. We want to find out if it is possible for us to swap. I can swap these equations in that I can bring some values from the left hand side and bring them to the right hand side, and those ones, I mean on the right hand side, bring them to the left hand side, and a value on the left hand side can be swapped to a value on the right hand side. I'm swapping so that I'm collecting whatever are like terms in this case. So when 2x crosses the equal sign, it will become a negative, so that I have 5x minus 2x is equal to, this is positive 9. My 3 is swapping with 2, so that the 3 comes in the position of 2. So 3, when it crosses the equal sign, it becomes a negative 3. So that 5x minus 2x will give us 3x. 3x will be equal to 9 minus 3, which is 6. So when I divide here by 3, divide by 3, my value for x will be 2. So it means that this equation can be simplified, we can obtain the value of our pronumeral by swapping whatever is on the left hand side and whatever is on the right hand side, such that the 3 on the left hand side has been swapped with the 2x on the right hand side. At the same time, the 2x is now coming in the position of the 3 on the left hand side. So when it is possible to swap whatever is on the right hand side with whatever is on the left hand side, then the equation qualifies to be called an equivalent equation. So let us just work out some few sums involving equivalent equations I mean. So we look at some questions that are instructing us to apply various operations when it comes to the equations. We are having such like a question. So the question instructs us to write the equation that will result from adding a 10 on both sides of this given equation. So we are adding 10 on both sides of the given equation and find out what value are we going to get. So we have 10d plus 5 is equal to 20. The question is instructing us to add 10 on both sides. So I add 10 on the left hand side. I add 10 on the right hand side. So when we add, then we need to find out which position or what numbers are likely to be simplified in this given equation. And we get that on the right hand side, it is possible for us to simplify because we have 20 plus 10, which are like terms. On the left-hand side, it is possible for us to simplify because we have 5 plus 10, which are also like terms. So we go ahead and simplify our equation so that 10d, we will have 10d plus 5 plus 10 gives us 15 will be equal to 20 plus 10, which is 30. So when we add 10 on both sides, then the equation that we come up with is 10d plus 15 is equal to 30. The next equation we have is 7e is equal to 31. The question is instructing us to get the equation that after adding 10 on both sides. So this means that on my left hand side I add 10, so I have 7e plus 10. On my right hand side I also add 10, so I have 31 plus 10, and we discover that on the left hand side the numbers that are on the left hand side are unlike terms, so they cannot be simplified further. But on the right hand side I have 31 plus 10, which are like terms and can be simplified, and 31 plus 10 will give us 41. So writing our equation means that the equation that we obtain after adding 10 on both sides will be 7e plus 10 is equal to 41. So adding 10 on both sides of this given equation gives us 7e plus 10 is equal to 41. So we are having two pairs of equations, and we need to find out if the two pairs of equations are equivalent or not. Remember, we had the 5 ways of showing that equations are equivalent. We can show that equations are equivalent by either adding a number on both sides, subtracting a number on both sides. Then we had multiplying a number on both sides that is not a 0, dividing a number on both sides and the number should not be a 0, and finally swapping the left hand side and the right hand side. So with these equations we need to apply the 5 rules and find out which one has been applied in each case, which amongst them has been applied. So the first equation is, we are having the equation 4x plus 2 is equal to 10. That is the first equation we have. The second equation is 4x is equal to 8. We need to find out, is the first equation equivalent to the second equation? And this is what is happening. If I take my second equation, that is 4x is equal to 8. If I have 4x is equal to 8, then we discover that if I add 2, if we decide to add 2 on both sides, so that on the right hand side I'm adding 2, on the left hand side I'm adding 2, what can we obtain from this equation? So that I have 4x on the left hand side, I'm adding 2, so 4x plus 2 is equal to 8 plus 2. So if I'm adding 2 on the left hand side, 4x and 2 are unlike terms, but on the right hand side 8 and 2 are like terms, so I can simplify so that I have 8 plus 2 will give us 10. So this equation will be obtained by, we will obtain 4x plus 2 is equal to 8. And we get that this, after adding 2 to the second equation, we are getting the same equation that is our first equation. So since it is possible to add 2 on both sides and get an equation that is similar to whatever we have as our first equation, then we conclude and say that these two equations, 4x plus 2 is equal to 10 and 4x is equal to 8, are equivalent equations. And we are saying that they are equivalent because it is possible for us to add a number on both sides, the left-hand side and the right-hand side of our second equation, and obtain the first equation. So that makes the two equations to be equivalent equations. The second example we have, so we are having 7 plus 3b is equal to 12, and the second equation we have is 9 plus 3b is equal to 14, and we need to confirm if the two equations are equivalent or not. So let us have a look at our equations. The first one, we have 7 plus 3b on my left-hand side. On my left-hand side for the second equation, we have 9 plus 3b. So we find that 3b and 3b are the same in the two equations. Whatever is different is 7 and 9. So what do I do to get the 7 or to get the 9? We have two options. If I'm going to use the second equation, then for me to get 7 from the 9, we subtract 2 from that 9 for me to get this 7. And if I have on the right hand side, I'm having 14 for the second equation. If I have to get the value on the right hand side for the first equation, then I'll simply subtract 2 from that second equation. So this is what we mean. I'm having 9 plus 3b is equal to 14. So if I decide and subtract 2 on that side, decide and subtract 2 on the left hand side, we will obtain the following equation. I'll have 9 minus 2 plus 3b is equal to 14 minus 2. So subtracting 2 on both sides, we obtain 9 minus 2 gives us 7 plus 3b will be equal to 14 minus 2 gives us 12. So we discovered that when we subtract 2 on both sides, when we are subtracting 2 on both sides, we are getting back the first equation that we have. So since it is possible to subtract a number on both sides and obtain an equation, so this means that we obtain a similar equation with whatever we have here. So since it is possible to obtain a similar equation from whatever is here, then it means that these two equations are equivalent equations. That is, 7 plus 3b is equal to 12 and 9 plus 3b is equal to 14 are equivalent equations because there is a number that I can subtract from the second equation both on the left hand side and the right hand side of the equation and obtain the same equation that we have as our first equation. So subtracting a number on both sides makes us to obtain a similar equation with what is here. So since it is possible to obtain a similar equation, we are saying that the two equations are equivalent equations. So we have another pair of equations, and the first equation I have is 18 is equal to 3x, and the second equation I have is 6 is equal to x. So we need to find out if the two equations are equivalent or not. The question we need to ask ourselves, is there any number that can simplify the first equation so that I get the second equation, or is there any number that I can multiply with the second equation so that I get the first equation? And we discover that if we decide and divide by 3, our first equation, if I divide by 3 on both sides, I'm having 18 is equal to 3x, so that if I divide the right hand side by 3, divide the left hand side by 3, we are having 3 into 18 is 6, and 3 into 3 we have 1. So we have 6 is equal to x, and 6 is equal to x is similar to whatever our second equation is. So it means that there is a number that I can divide on both sides, our first equation, and I obtain the second equation that has been given. Since it is possible to divide by a number that is not a 0, 3 is not a 0, so it means that this equation on the first equation and the second equation are equivalent equations. So we have 4 into 10 plus b is equal to 80, not 8, so we are having 80, and 10 plus b is equal to 20. We need to find out if the two equations are equivalent or not. So this means that if we get a number that we can either add, subtract, multiply, divide, then it means that the two equations will be equivalent. Or alternatively, if we can swap whatever we have on the right hand side with whatever is on the left hand side, then it will make our equations equivalent equation. So what is happening here? We have 4 into 10 plus b is equal to 80, and 10 plus b is equal to 20. We discover that in this case, the second equation, for us to obtain the first equation from the second equation, we can multiply by 4 on both sides. So I'm having my second equation, that is 10 plus b is equal to 20. So 10 plus b is equal to 20. If we multiply both sides by 4, so that I have on the left hand side times 4, on the right hand side times 4, we will get 4 into 10 plus b is equal to 20 times 4 gives us 80. So we find that 4 into 10 plus b is equal to 80 is similar to the first equation that we have. So since the two equations have a number that we can multiply on both sides and obtain one of the equation, we can multiply by 4 to obtain the first equation. Then it means that 4 into 10 plus b is equal to 80 is equivalent to 10 plus b is equal to 20. So the question is asking us to match up each of these equations with its equivalent equation. So we need to find out which equation is equivalent to whatever equation that we've been given. The first equation we have is m plus 10 is equal to 12, and we need to find an equivalent equation to m plus 10 is equal to 12. We discover that m plus 10 is equal to 12. We can subtract 10 on both sides, so that I'm having m plus 10 minus 10 is equal to 12 minus 10. So when we subtract 10 on both sides, we obtain m is equal to 12 minus 10 gives us 2. So this means that the equivalent equation to the whatever we've been given, m plus 10 is equal to 12, is equivalent to the equation. It is equivalent to equation m is equal to 2. In that, it is possible to subtract 10 on both sides of this given equation and obtain the second equation. So since we can subtract a number on both sides and obtain the second equation, then it means that the two equations are equivalent equations. 12m is equal to 30. We need to obtain an equivalent equation to 12m is equal to 30. So looking at the equation, there is a number that I can divide on the left-hand side, and the same number I divide it on the right-hand side of the given equation and obtain an equation. So we find that if I divide the left-hand side by 6, divide the right-hand side by 6, we obtain an equation that is 6 into 6 ones into 12 to 6 into 6 ones and into 30, we have 5. So the equation that we come up with, we have 2m is equal to 5. So this means that 2m is equal to 5 is an equivalent equation to 12m. 12m is equal to 30. What is the reason? We are saying that there is a number that I can divide on both sides of the equation. 12m is equal to 30 and obtain 2m is equal to 5. And the number is 6. If I divide 6 on the left-hand side, divide 6 on the right-hand side of this given equation, we are obtaining 2m is equal to 5. So it means that this equation 12m is equal to 30 is equivalent to 2m is equal to 6. Sometimes two equations that may look different can be equivalent in one way or another. So let us look at two different equations, two equations that look very different from one another, but they are equivalent. They look different from one another, but are equivalent. For example, we have this equation. So looking at the two equations, we have 3x plus 2 is equal to 14. And the second equation we have is 10x minus 1 is equal to 41. We need, the two equations look completely different from one another. We find that we can't have any relationship between the two of them. But when you take various steps from a given equation, you discover that it is possible to have two equations that are appearing to be totally different from one another being an equivalent equation. So whatever we have is this. We have 3x plus 2 is equal to 14. On the other equation we have is 10x minus 1 is equal to 41. We need to confirm it is 10x plus 1 is equal to 41. We need to confirm if the two equations are equivalent or not. So taking various steps, let us start. We first said that an equation can be equivalent if there is a number that can be added on both sides, subtracted on both sides, multiplied on both sides as long as the number is not 0, divided on both sides as long as the number is not 0. Then we will say the two equations are equivalent. So let us take our first equation. This is 3x plus 2 is equal to 14. Looking at this first equation, if I want to get an equivalent equation to this, then it is possible to subtract 2 from both sides because I'm having a positive 2. So if I decide and subtract 2 on both sides, so that I will have 3x plus 2 minus 2 will be equal to 14 minus 2. This gives us 3x, 2 minus 2 is 0. So 3x will be equal to 14 minus 2 gives us 12. So 3x will be equal to 12. From there, we discover that this is an equivalent equation to the first one we had. We had 3x plus 2 is equal to 14. So I've subtracted 2 on both sides. And after subtracting 2 on both sides, we are obtaining 3x is equal to 12. If we add 3 on both sides of the equation that we have, supposing we add 3 on this side and add 3 on that side, so that I will have 3x plus 3 will be equal to 12 plus 3. So on the right hand side, 12 plus 3 can be simplified so that we are getting 12 plus 3 is 15. And on my left hand side, I have 3x plus 3. Then we can multiply throughout by 3, by 10, so that if we multiply throughout by 10, we multiply on the left hand side by 10, multiply on the right hand side by 10, whatever we are obtaining is we are going to have 3x plus 3 multiplied by 10. So we have into 10, 10 into 3x plus 3 will be equal to 15 times 10. So if I simplify and open up my brackets, then I have 10 times 3x, and 10 times 3x gives us 30x. Then 10 times 3 gives us 30, will be equal to 15 times 10 is 150. I'm looking for a way in which I can get my 10x. So this means that if I divide this given equation, if we decide and divide through by 3, so I divide here by 3, divide by 3, divide by 3, then we are going to get, this is 10x plus 10 is equal to 50. So from here, it is possible to obtain this given equation, in that the only thing that is left, we have the 10x, this is 10, this is 41. This is 10, this is 1, this is 41, this is 50. So we need to make our 10 to be 1, we need to make our 50 to be 41. So what does that mean? If I subtract on the left-hand side minus 9, I subtract on the right-hand side minus 9, then I'll have 10x plus 10 minus 9 is equal to 50 minus 9. And 50 minus 9 is 41. 10 minus 9 is 1. So I'll have 10x plus 1 is equal to 41. So this means that this equation 3x plus 2 is equal to 14 and 10x plus 1 is equal to 41 are equivalent equations, even though we have to go through various steps to find out if they are equivalent or not. So since we now have the knowledge that an equation can be made to be equivalent by either adding, subtracting, multiplying, or dividing a number, or possibly swapping the right-hand side and the left-hand side, then it means that we can now solve the given equations systematically by either adding, subtracting, multiplying, dividing, or swapping the given numbers. So we need to find out how do we solve these equations systematically. So the first example we have where we need to solve the equations systematically, we can meet equations where they will involve one step or even more. So where the equation is requiring us to carry out more than one step, then we will carry the steps until we get the solution to the given equation. But where the equation has only one step, then our solution is simple. So we can try out some questions that are involving, requiring us to solve the given equations. So we have the equation 6m is equal to 54. We need to solve it systematically. So we need to find out which steps are we supposed to follow for us to be in a position to solve this given equation. 6m is equal to 54. For us to solve it, we need to get the value of our prenumeral, which is m in this given case. To find the value of m in our equation, we will obtain it by taking the step of dividing both sides by 6. So divide the right-hand side by 6, divide the left-hand side by 6. So that I will have 6m over 6 will be equal to 54 over 6. So we said that solving an equation involves getting the value of our unknown, and the unknown in this case is m. So to get the value of m, we divide the left-hand side by 6, divide the right-hand side by 6, so that 6 into 6 once, 6 into 54, we have 9. So getting the value of m, in this case, our m is equal to 9. So we've solved the equation systematically by dividing both sides by 6. We have the equation s times 9 is equal to 72, and we need to solve the equation systematically. So this means that we are having a multiplication. We need to get the value of s in our equation. So s, to obtain the value of s, we divide the left hand side by 9, divide the right hand side by 9. When we divide the right hand side by 9 and left hand side, 9 and 9 cancels out. So we are left with s is equal to 72 divided by 9. 9 into 9 once, then 9 into 72 is 8. So we get the value of s is 8. So that is the solution to that given equation. Seven plus t is equal to 9. We need to get the value of our prenumeral, which in this case is t. So to get the value of t, we will subtract 7 on both sides, so that on left hand side I subtract 7, on the right hand side I subtract 7 to obtain 7 minus 7 plus t is equal to 9 minus 7. 7 minus 7 is 0, so on the left hand side I'm left with t is equal to 9 minus 7 gives us 2. So the solution to our equation is that the value of t is equal to 0. The value of t is equal to 2. So we have another equation, 2 is equal to y minus 7, and we need to find the value of y in this given equation, so that we have minus 7 on the right hand side. For us to get the value of y, we will obtain y by adding 7 on both sides. So I add 7 on the right hand side plus 7 on the left hand side, so that the equation that we have is 2 plus 7 will be equal to y minus 7 plus 7. Y minus 7 plus 7, this is negative 7 plus 7 gives us 0. So on the right hand side I'm left with y. The left hand side we have 2 plus 7. 2 plus 7 is 9. So it means that the value of y in this case is equal to 9. We've obtained that by adding 7 on both sides. Those are just examples of questions that have only one step to be carried out. So in this case, we are having only one step that is being carried out, either adding, subtracting, dividing, or multiplying. We are only carrying out one step. But let us look at an example that is involving us to carry out various steps. So a question that is requiring us to carry out several steps, we have in an example on the board. So we have 7 is equal to 10c minus 3. So this means the first step that I have to carry out for me to solve this given equation is adding 3 on both sides. So we are adding 3 on the left hand side plus 3 will be equal to 10c minus 3 plus 3. So minus 3 plus 3 gives us 0. 10 plus 3 is 10 will be equal to 10c. To get the value of c, the second step that we take is divide by 10 on both sides, divide by 10, divide by 10, so that the value of c in this given equation will be 10 divided by 10, which is 1. So our value for c in this case is equal to 1. So this means that we've carried out two steps. The first step is adding 3 on both sides. So I add 3 on the left hand side and the right hand side. The second step is dividing by 10 on both sides. So divide by 10, divide by 10, so that we obtain the value of our unknown. And in this case, after dividing 10 on both sides, the value of our unknown is equal to 1. Maybe just the last example. So we have 3 is equal to 8x plus 1 divided by 2. So this can be written as 8x plus 1 over 2. So having that, it means the first step to carry out is multiply by 2 both sides. So we multiply by 2, multiply by 2, so that 2 and 2 cancels out. 2 times 3 gives us 6, will be equal to 8x plus 1. The second step that we carry out is minus 1 on both sides, so that I have 6 minus 1 will be equal to 8x minus 1. 8x plus 1 minus 1, so that plus 1 minus 1 is 0. 6 minus 1 is 5, is equal to 8x. For us to get the value of x, divide by 8 on this side, divide by 8, so that our value for x is given by 5 over 8. So we are having 3 steps that have been carried out. The first step was multiplying by 2 on both sides. So we multiply by 2. The second step was subtracting 1 on both sides, and the last step that we've carried out is dividing by 8 on both sides. So those are some of the steps that are carried out. So we've been looking at equivalent fractions, equivalent equations. And these equivalent equations, we've said that they can be obtained by either adding, subtracting, multiplying, or dividing a number that is not a 0 on both sides. Then the equations will be equivalent. Looking at the steps, there are various ways in which you can solve an equation. There are equations that will involve one step, and there are equations that will involve various steps for you to reach to the solution of the given pronumeral in the equation. So find out for yourselves various equations, then find out which steps to be carried out in order to get the solution to the given equations. Thank you.